This is the brief on string oscillation boundary conditions. So we're going to break down the physics of wave reflection. But, you know, not just any wave. We're looking at what happens when a string is tied to a little mass ring that can slide up and down instead of just being nailed to a wall. This is what we call a dynamic boundary, and it completely changes the game. First up, it all comes down to a classic, Newton's second law. You've got the string pulling on the ring, right? Well, that force has to equal the ring's mass times its acceleration. It's this perfect balance that dictates exactly how the end of that string is going to move. Second, and this is crucial, the size of that ring's mass is everything. If the mass is practically zero, like super tiny, it has almost no inertia. And what happens? The string acts like it's totally free. You get this classic free end reflection where the wave just bounces right back without flipping over. And finally, simulations just prove how cool and tunable this whole thing is. I want you to think of the ring's mass like a dimmer switch for the boundary. A really heavy mass, that makes the wave bounce back like it hit a solid wall. A super light mass, you get that predictable free end reflection we just talked about. It gives you this amazing control over the whole system. So in the end, the interplay between mass and motion defines exactly how energy reflects at the string's endpoint.